All right, let's take a look at this one. We've done them with tables before, exponential tables, but these are a little bit different because we have some gaps in there that we didn't have before. So, where we normally do our division here, which would look like in this case 256 divided by 212, we get a 1.207547, so we'd keep the 1.2075, but that's if we need to jump 2 years ahead. So this talks about years here. So a 2-year jump means multiply by 1.2075. Now that could probably get us back to the 0 here as well, so we could take the 212 and divide by 1.2075 to figure out that the year 0 is about 176. Now that doesn't, however, give us the growth factor, because the growth factor is a yearly thing. So how do I get from one year to the next? And so the idea here is what's happening here is the 212 got multiplied by my base, or my growth factor, to get some number here that I don't know, and then that got multiplied by the base again. So what I really have is an equation here that says 212 is equal to, or 212 is not equal to, 212 times b again, times b is equal to 256. But that's 212 times b squared, that equals 256. If I divide by 212 on both sides, I will get that b squared is equal to my 1.2075. Okay. The other way to think about this, I need to get the squared off of the b. That's not something that we have done before. But the idea is that I only want to go halfway to this 256. I only want to take half of this journey. So what I'm going to do is I'm going to take that 1.2075. I'll get it back on my screen by doing the 256 divided by 212. And I'm going to raise that to the 1/2 power. Now on most of the calculators, you're going to have to put a parentheses and a 1 divided by 2 up there. Yours won't show it as an up there. It's going to show it a little bit differently on there. But we want that 1.2075 caret symbol, 1/2, because we want to only go half the distance. And it says if you want to just do half the distance of that, then what you're going to multiply by is 1.0989. So that's what my growth factor is. My initial value here is a 176. I can test this now. Let me go with the 176, and I'll enter that, and I'll multiply by 1.0989, and it says my next one should be a 192 to the nearest, and if I hit it again, hopefully it'll give me the 212. Only a 209, huh? Okay. So let me try to figure out what is going on there. Okay, I spotted it. Common mistake. If you look on my calculator, instead of putting 1.0989, I put 1.898. So I got my 8s and my 9s mixed up. I'm going to try that again. So this is probably not a 192. Love a good eraser. Let's try it again. 176 times 1.0989, and that's a 193. And if I hit the enter again, times 1.0989, enter. There's my 212. It's pushing it up closer to a 213, but pretty close. 234 feels like it fits there. 256.6, probably in some rounding that I did somewhere. it didn't like as much, but still very close. 282, if I'm within 1, I feel like I'm doing all right. Okay. So that is the example problem there. Now, moving to these next ones, I got to pay attention now to the spacing on things here. This jumps from 0 all the way to 3. So my 976 divided by 1231, that's going to be b to the third power, because it's going 3 times, and so I only want to go to 1/3 of that. So I'm going to raise that to the 1/3 power. Okay, I'll do this on my calculator here. 976 divided by 1231 is 0.792851. I am going to raise that now to the 1 divided by 3 power. Make sure the parentheses are around there, especially on the older calculators. And that's going to give me a growth factor of 0.9255. Keep that for decimal places. 1231 I could see was the initial value. Now, I'm going to put my 976 in. And I can do this a couple of different ways. I'm going to multiply by 0.9255. 976 was for 3, so this is for 4. One more time will get me 5. One more time after that will get me 6. So that looks like a 774. One more time will get me 7. And one more time gets me the 8. And once more after that is the 9 at 613. Okay? Growth factor is a number between 0 and 1. These are going down. This is exponential decay. Okay? Gap here is 3 again, so I'm going to start with my 595 divided by 326. 595 divided by 326 is 1.8251. 1.8252. But I only want to go 1/3 of the way again. The difference between the 1 and 4 is 3, so I'm going to raise this again to the 1 divided by 3 power. And that's going to give me a growth factor of 1.2221. Okay. So to get back to the initial value, I'm going to need the 326 divided by 1.2221. That'll give me a 267. Round those. Now I'll go back to the 326 again and multiply by my 1.2221. To get to the 2, that's a 398. Hit it again. 487. Hopefully something close to 595. Very close to 595. 727 for that one. My initial value I figured back there was a 267. Okay. All right. Gap here is 4. It does give me my initial value. I can see that at the 179. I'll do the 112 divided by 179. These are getting smaller, so I expect to get a number that's less than 1. And that's 4 jumps. So again, the 112 over 179 gave me a 0.6257. And I want to take that thing, this one up here, I raised to the 1/3 power. This one I'm going to raise now to the 1/4 power. So raise, parentheses, 1 divided by 4, and I get a growth factor of 0.8894. So I'll start with the 179 times 0.8894 drops it down to a 159 times 0.8894 is a 142, and again takes me to a 126. And I nail the 112 very closely there, and my next one's a 99.6, which rounds to 100. We'll come down, we'll do these other things at the bottom later. Okay, gap here, got to pay attention. The gap is 2. Okay. So I'm going to take my 3812 and divide by 3712. 3812 divided by 3712 gives me a 1.0269, which I am going to raise to the 1/2 power. Raised to the 1 divided by 2 power. And I get a growth factor of 1.0134. I'll put my 3712 in there. Got to start backing up now. I'm going to divide by my 1.0134. That would take me to 5. Once more would get me down to 4, so this should be 3614 there. 3, 2 gives me to the 3520. 1, 0 is at 3427. So the initial value is 3427. Now I'm going to do this a little bit differently. My equation for number 4 would be initial value 3427 times 1.0134 raised to the x power. I'm going to use this equation to find the 11. So I'm going to put my 3424 in times parentheses 1.0134 raised to the 11th power, and that should give me a 3964. So 3964. Okay, so I can use the equation once I have the growth factor and the initial value to fill in things as well. Okay, between -1 and 2, that's 1, 2, 3 jumps, so 6791 divide by 13,252. 6791 divide by 13252 gives me a 0.5125, which I am then going to raise to the 1/3 power. So raised to the 1 divided by 3 gives me a growth factor of 0.8002. Okay. I'll start with the 13,252 and divide by 0.8002. That gives me a 16561. Now if I put in the 13,252 again and multiply by 0.8002, one jump there takes me to a 10,604, 8,486. Hopefully the 6791, very close to that. Some of my rounding here probably threw that off a little bit, but not by too much. And 5433. So my initial value was that 10,604. Could write that equation, 10,604 times 0.8002 to the x power. do this last one, then fill in the rest of our equations. In fact, I'll do some equations now. 1, 2, 3, 1 times 0.9255 to the x power. The second one, initial value is 267 times 1.2221 to the x power. Initial value 179 times 0.8894 to the x power. And the last one, gap of 3 again. It doesn't show them all, but the distance from 0 to 3 is definitely 3. So my 3492 divided by 1746, 3492 divided by 1746 is exactly 2. And the 2 I'm going to raise to the 1/3 power. Okay? Raised to the 1 divided by 3. And that's a 1.2599. Initial value is a 1746, so I could already at this point write that this is a 1746 times 1.2599 to the x power. There's kind of some bigger gaps here, so maybe I want to use that to find the negative 5. 1746 times 1.2599 raised to the negative 5 power is a 550. 1746 times 1.2599 raised to the negative 1 power is a 1386. 1746 times 1.2599 just one time takes me to, that would round to a 2,200 on there. So the 2199.78. And to the 10th power, 1746 times 1.2599 raised to the 10th power is a 17596. Okay, that's jumping 7 times up there, so really kicking in with some of that extra growth there. Okay, so that is how we adjust for when our tables don't give us exact consecutive values, but give us two values that are somewhere in there. The gap between them, we use that as a fractional power to help us find out what those individual ones are going to be.